X-rays. And from this came the realization that photons actually can have the property of momentum. And even though they're particles without mass, because it equals mc squared, we can have particles without mass having momentum. That's a fantastic result. And we solve problems with energy and momentum. We also realized that there's a special equation called the Compton equation, which ties together, various ideas here. And it says the change in the wavelength before and after is equal to h divided by the mass of the particle that's ejected times the speed of light times 1 minus the scatter angle of the photon, not the particle. That was actually a question on exam one year. What is that angle? Is it the photon or the particle? It's the photon. So make sure you know how to solve this and this. There's questions on both tomorrow. Then we met Louis de Broglie, who said, well, listen, if you guys are so sure that waves can act like particles, can particles act like waves? And he came up with this de Broglie matter wave equation. You'll notice that it's not on the data sheet because it's a simple derivation of these two. So, you may need that tomorrow. Make sure that you walk in with that ability to get to that, memorize it or just calculate it out. And so we can solve for particles very small, moving at high speeds, and they have measurable wavelengths, right? But they don't become waves, that's just how they behave. We talked briefly about the particle in a box idea that suggests that when we're modeling the behavior of small particles, come in. More guys out there too? Is that for me? Fantastic. Yes. 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 Yes.
So we're gonna watch this later.
Yeah.
Yeah.
Fantastic.